if the 1,500-pound boom AB, the 200-pound cage BCD, and the 175-pound man have centers of gravity located at points G1, G2, and G3 respectively, determine the resultant moment produced by each weight about point A. Okay, so all we're doing is practicing calculating moments of forces about points. That's what we're doing in these problems. So we're not thinking about, at this point, we're not thinking about what these moments mean, or how do we analyze the problem once we have the moments. We're going to do that later. We just want to find moments about certain points. And you can imagine that, so this boom here is 1,500 pounds, and the moment is saying, so this, you can put the weight at the center of gravity, G1 of the boom, and you can imagine that the moment of the boom about this pivot point, right? What's the moment? The tendency of the weight of the boom to cause rotation about this point. That could be of interest to us, right? We could calculate the moment of this of the weight of the boom, the force weight of the boom about this point. But what is that telling us, right? But you can see how that might be of interest to us to find the weight, the tendency of all of this to cause rotation about point A. Okay, so let's find these moments. This is another planar problem. So all of these forces lie in a single plane. And then also you can think about how, the whole system is symmetrical to that plane. So you can simplify this by making it a planar problem. Now, okay, so all weights act towards the, just downward toward the center of the earth. And when we find moments in a plane, typically we don't use R cross F, but you can. The common practice is to break the forces down into their components, and then find them, and then it's easy to get the moment arms of the components and just sum all of the moments up. But just a reminder, go watch the previous videos. It's easy to forget about the R cross F definition of the moment and the true moment arm, that perpendicular distance from the net force, from the actual not component of the force, but the net force to your point. But this is what we do in a plane typically. Okay, so let's do force. Well, okay, the boom. We'll start with the boom. And so our coordinate system we'll say is Z, X, Y. And so for the boom, we've got this G1, this force here is causing a clockwise rotation, so it's going to be a negative moment. What's the moment arm? It's this distance here. So we've got the moment of the boom, the moment about point A of the boom is equal to, so negative 1,500, and then times, now the moment arm is 10 cosine of 75, right? You see that? Okay. times 10 times cosine 75 minus 3882. And that's foot-pounds. Okay, now the cage. The moment about point A of the cage. This is also going to be clockwise. All of these forces is going to be a clockwise rotation. So we've got 200. So this is going to be minus 200 times. So we have 30 cosine of 75, right? That's this horizontal distance. So 30 cosine 75 plus 2.5. So 30 times cosine of 75 plus 2.5 minus 2053. And that is foot-pounds. Okay, now the man. So the moment about point A of the man is also going to be negative, and he's 175 pounds. It's hard for me to believe that this entire cage weighs 200 pounds, and the man weighs 175 pounds, but okay. So it's just 300 cosine of 75 plus 2.5, which was 10.26. Plus 1.75. So the moment about point A of the man, 10.26 plus 1.7075 times negative 175 minus 2102.